Hi everyone, we are back with another video today. Today we are solving this math paper. Paper 1, Pure Mathematics 1, 9709, paper 1-3 from the October-November 2023 series. The time is 1 hour 50 minutes. We get access to the formula list MF19 and all non-exact numerical answers should be given correct 3SF or 1 dp for angles in degrees specifically, unless a different level of accuracy is specified in that particular question, and the total mark is 75. So before we start, I just wanna talk about my Patreon. If you guys do like my videos, please consider supporting me by subscribing to the channel. It helps with the algorithm a lot. I will be rolling out more math videos soon, like statistics, mechanics, Pure Math 1 as well as Pure Math 3. So if you need more help, all the help is available on Patreon. There are currently 3 tiers available. The first tier is at $5 a month for general support, and the most popular tier is for $20 a month, where you get access to all my solved papers for math P1, P3, M1, and S1, as well as for chemistry, physics, and bio paper 1, 2, 4, and 5, and ad-free videos on Patreon. And for the ultimate learning experience, the highest tier, you get access to all those perks, as well as one-on-one video meetings with me once or twice a month, where we solve your personalized problems, as well as being featured on the end screen on each of my videos, as long as you're subscribed. Anyway, let's start. So let's take a look at the threshold first. I just solved component 1-1 recently. So for component 1-3, it seems that this paper is a bit easier than the other two, since A is at 62, B is at 56, C at 45, D at 34, and E at 23. So let's write that down here. So the maximum raw mark is 75. A is at 62, B is at 56, C is at 45, D is at 34, E is at 23. So A star, logically it's supposed to be really high up, because this was like 8 marks above this, so it should be at around 69 or 70, somewhere like that. Honestly, very hard to get. 69, 70, or 71, something like that. So there was almost no room for error, since everyone did so well in this particular paper. Okay, let us begin. So quick look at the paper. How many questions do we have? In total we have 11, I guess. Yes, 11. So my target is to finish the paper within 1 hour. Let's see how we fare. A curve is such that its gradient at a point xy is given by this. It is given that the curve passes through the point 4,1. Find the equation of the curve. Okay. So dy by dx is x minus 3x to the power minus half. So y will be its integral, right? So x squared by 2 minus 3x to the power plus half divided by half plus c. So y is equal to x squared by 2. The 2 will go on top, minus 6x to the power half plus c. So we know the coordinates. It's 4, 1. So 1 is equal to 4 square, 16 by 2, minus 6 root 4 plus c. 1 is equal to 8 minus 6 2 is 12 plus c. So 1 minus 8 plus 12. So c is 5. So y is basically x squared by 2 minus 6 root x plus 5. That is the answer to this question. I'll just check the mark scheme real quick. This is paper 1-3. Half x squared minus 6x to the power half plus 5. Perfect. The circle with equation this intersects the y-axis at points A and B. Find the y coordinates. Okay. So if we intersect the y-axis, at that point the x coordinate will be 0. At this point, x coordinate 0. So let's try doing this, shall we? Okay, so minus 3 square plus y square minus 10y plus 25 is equal to 40, or 9 plus y square minus 10y plus 25 is equal to 40, or y square minus 10y, and we have 9 plus 25 minus 40, which is minus 6, is equal to 0. So since they wanted in terms of surds, we have to apply the general formula. So y is equal to minus b, so that is plus 10 plus minus root over b square minus 4ac. So b square minus 10 whole square, 100 minus 4ac, 1 into minus 6 divided by twice a, 2 times 1. So it's 10 plus minus root over 4 times 6. So that is 124. What is root 124 though? 2 root 31. Okay. 10 plus minus 2 root 31 by 2. So that is y is equal to 5 plus minus root 31. These are the y coordinates of A and B. 5 plus minus root 31. That is our answer. Good to go. Find the equation of the circle which has AB as its diameter. So we need the x coordinate, right? Oh, we already have the x coordinate. It's 0. So the coordinates are 0, 5 plus root 31, and the other one is 0, 5 minus root 31. So our goal here is to find the midpoint. We are going to find out the midpoint. So let's do that. Center. The midpoint is basically the center, yeah? So the center will be 0 plus 0 by 2 plus 5 plus root 31 plus 5 minus root 31 by 2. Okay. So that is 0. We get rid of this. 10 by 2 is 5. So this is our center. Fine, perfect. Now about the radius, right? So the diameter is actually root over 0 minus 0 whole square plus 5 plus root 31 minus 5 plus root 31 whole square. So root over 0 square plus 2 root 31 whole square. So that is actually root over 0 plus 2 root 31 whole square, which is 124, or root 124, which is basically 2 root 31. That's the diameter. So the radius will be half of this, 2 root 31 by 2, which is just root 31. Fine. So now we find out the equation of the circle. How? This is the center. So x minus 0 whole square plus y minus 5 whole square is equal to root 31 whole square, or x square plus y minus 5 whole square is equal to 31. That should settle as our answer. X square plus y minus 5 whole square is equal to 31. Perfect. Okay, smooth so far. Moving on to question number 3. Show that this equation may be expressed in this format. Let's try. 5 cos theta minus sin theta tan theta plus 1 equals to 0. So 5 cos theta minus sin theta into sin theta by cos theta plus 1 equals to 0. 5 cos theta minus sin squared theta by cos theta plus 1 equals to 0. So finally 5 cos squared theta minus sin squared theta plus cos theta by cos theta is equal to 0. Now what? We have to apply the identity, yeah? 5 cos squared theta minus 1 minus cos squared theta plus cos theta equals to 0. So 5 cos squared theta minus 1 plus cos squared theta plus cos theta equals to 0. So we get 6 cos squared theta plus cos theta minus 1 equals to 0. Shown answer. He'll solve this equation. Fine. We will solve it. So we have 6 cos squared theta plus cos theta minus 1 equals to 0. So I've been watching Shogun recently. It's so good. I'm currently at episode 5. I'll finish the season by this week. I've been binging it. So good. I really like shows with politics, like this one, the Game of Thrones, Attack on Titan, anything with politics is just insane. Okay, so let's solve this. So 6 cos squared theta, 3 and 2, right? Plus 3 cos theta minus 2 cos theta minus 1 equals to 0. So we can take 3 cos theta common. We have 2 cos theta plus 1 minus 1, 2 cos theta plus 1, 3 cos theta minus 1, 2 cos theta plus 1. Okay, so we have two answers now. One of them is cos theta is equal to 1 by 3. The other one is cos theta equals to minus 1 by 2. Make sure you have your calculator in radians, because the domain is from 0 to 2 pi. So cos inverse 1 by 3. So that is 1.23. One basic acute angle, the other one is minus 1.23. Over here, cos inverse minus half is 2 pi by 3 and minus 2 pi by 3. So that is the rule for cos, right? I talked about this in my last video. Watch that if you haven't already. ON23 paper 1.1. But the rule for cos alpha is just basically go for alpha and minus alpha. For sine alpha, it is alpha and 180 minus alpha. And for tan, it is alpha and 180 plus alpha. This is the basic acute angle. You will input the sine. It will be included when you do it in the calculator. Now I'm looking for 0 to 2 pi. What does 2 pi mean? It actually means 6.28. Yeah, 6.283. So clearly, to get more answers, I need to add 2 pi with the negative 1, right? So we know that it was cos inverse 1 by 3 minus answer plus 2 pi. That gives me a value of 5.05. And for this negative 1, minus 2 pi by 3 plus 2 pi, that gives me a value of 4 pi by 3, which is within the domain. It's 4.18. This is 4.18, which is less than 6.23. And 5.05 is also less than 6.23. So therefore, our final answers are 1.23, 5.05, and these two are exact answers. 2 pi by 3, since it's exact, and 4 pi by 3. There you go. These are our final answers. Now we have binomial expansion. Expand the following in ascending powers of x up to and including the term in x square. Okay. So let's go for this. 1 plus 2x to the power 5, 1 to the power 5, plus 5c1, 1 to the power 4, 2x to the power 1, plus 5c2, 1 to the power 3, and 2x square. So that's 1 plus 5 to the 10. 10x plus 5c2. What is the value of 5c2? 10. 10 times 4, that's 40x square. Okay. And this, okay. 1 minus ax to the power 6. 1 to the power 6 plus 6c1, 1 to the power 5 minus x to the power 1 plus 6c2, 1 to the power 4 minus ax whole square. Okay, so that is 1 minus 6 ax plus, what is 6c2? 15 plus 15 a square x square. That is what they wanted, right? Okay, that's good. 1 minus 6x plus 15 a square x square. Now in the expansion of this, the coefficient of x square is minus 5. Fine. So let's write this down. 1 plus 10x plus 40x square times 1 minus 6ax plus 15a square x square. The coefficient of x square is minus 5. So how to get the coefficient of x square? Multiply this by this one by this, and this one by this. Then you'll get the coefficient of x square. Okay, so it's 1 times 15a square plus 10 times minus 6a plus 40 times 1. That gives you a value of minus 5. So 15a square minus 60a plus 40 is equal to minus 5. 15a square minus 60a plus 45 equals to 0. So a square minus 4a plus 3 is actually equal to 0. So how to do this? It's 3 and 1. Minus 3a minus a plus 3 equals to 0. A minus 3 plus 1, sorry, minus 1 a minus 3. So a minus 1 a minus 3 equals to 0. A is equal to 1 and 3. These are the possible values of a, and we will accept that. Great. Moving on to question number 5. The first, second, and third terms of a geometric progression are 2p plus 6, 5p, and 8p plus 2 respectively. Find the possible values of the constant p. These are parts of a geometric progression. So a is equal to 2p plus 6, ar is equal to 5p, and ar square, the third term, is equal to 8p plus 2. So we can actually write that the common ratio is actually equal to 5p by 2p plus 6 is also equal to third by second term, 8p by 2 by 5p. Okay. So if you want, you can solve this. 25p square is equal to 8p plus 2 times 2p plus 6. 25p square equals to 16p square plus 48p plus 4p plus 12. So 25 minus 16. 25 minus 16 is 9p square. 9p square. 48 plus 4 is 52. Minus 52p minus 12 is equal to 0. You can divide this. No, you can't. You can't divide by 3. Fine. So if you solve this, I'm just using the calculator. 9 minus 52 minus 12. We get 6 and minus 2 by 9. Okay, so we get 9p plus 2 and p minus 6. So p is equal to 6 and p is equal to minus 2 by 9. These are the possible values of p, since they did not say anything about the sign of p, right? So these two work. One of the values of p found in a is a negative fraction. Okay. We have our one. Use this p to find out the value of sum to infinity. So find out the first term first. 2p plus 6. So that is minus 2 by 9 into 2 plus 6. Minus 4 by 9 plus 6, that is 50 by 9. Now we have to find out the value of r. So r is 5p by 2p plus 6. Okay. So 5p, which is minus 10 by 9, and 2p plus 6. The first term, it was 50 by 9. So minus 10 by 9 divided by 50 by 9. That is minus 1 by 5. Fine, perfect. So now let's find out the sum to infinity. It's a divided by 1 minus r. It's in the data sheet. So a, first term, 50 by 9 divided by 1 minus 1 by 5, which is 50 by 9 divided by 1 plus 1 by 5, which is 6 by 5. So if you do the working, 50 by 9 divided by 6 by 5 is actually 125 by 27. Perfect. That matches with the mark scheme. We are at question 6 now. a line has equation 6x minus c, and the curve is equation cx square plus 2x minus 3, where c is a constant. The line is a tangent to the curve at point P. Find the values of c and corresponding coordinates of P. Okay, so it's a tangent, so it meets once, so the discriminant is equal to 0. Let's do this. Let's make them intersect. So put them on one side. Okay. So b square minus 4ac is actually equal to 0, since we know that it's a tangent at point P. So minus 4 whole square minus 4 into c minus 3. So 16 minus 4c. 16 minus 4c square plus 12c. Or 4c square minus 12c minus 16 equals to 0. C square minus 3c minus 4 equals to 0. So it's c square. It's 4, right? 4 and 1. Minus 4c plus c. So c minus 4 plus 1, c minus 4 equals to 0. C plus 1, c minus 4 equals to 0. C is equal to minus 1 and 4. So these are our possible answers. Minus 1 and 4. And the corresponding coordinates of P. Okay. So we have the value of C now. So let's try to solve this, okay? So we know that this was the main equation. So if we input 4x square minus 4x plus 4 minus 3, which is plus 1 equals to 0. So if you solve this, I'll just use my calculator. Half. We just get half. So 2x minus 1. 2x minus 1 whole square equals to 0. X is equal to plus half. And if you input minus 1, so minus x square minus 4 into minus 1. Minus c minus 3, minus 1 minus 3, which is minus 4. Minus x square plus 4 minus 4 equals to 0. Sorry, I made a mistake over here, my bad. Minus x square. Minus 4x minus 1 minus 3. Minus 4 equals to 0, or x square plus 4x plus 4 equals to 0. So minus 2. So it's x plus 2 whole square equals to 0. So x is equal to minus 2. There you go. So these are our coordinates. Now we need y. Y is equal to 6x minus c. So half into 6 is 3. And we input x is equal to 4 over here. So x equals to 4. So it's half minus 1. And over here, y is equal to 6x minus c. Minus 2, 6, that's minus 12. Minus c. Sorry. X equals to minus 2. So, sorry, it should be c over here, yeah? So, y is equal to 6 into minus 2 minus 12. Minus, which is plus 1, which is minus 11. So, we actually end up with minus 2 minus 11, okay? Minus 2 minus 11. That is all. These are our answers. Half and minus 1 and minus 2 minus 11. Moving on to number 7. The function f is defined by fx is equal to this for x is greater than 2. State the range of f. Okay, so the best way here is to draw a graph actually. So it starts from 2. One plus 3 divided by x minus 2. So if you input 2, 2 is actually 2 is an asymptote. Okay, so we will instead input 3. So at 3 we get 4. There you go. And what about at 2.5? We get 7. At 2.5 we get 7. So it's clear as day that it's going to be an asymptote here. Okay. So what about 4? At 4 we get 2.5. 4 we get 2.5. At 5 we get 2. At 10 we get 1.375. At 100 we get 1.03. So clearly there is another asymptote. It's at 1. Never reaches 1. Understood? So the graph is kind of like this here. So as you can see, the range, it is always above 1. It is always above 1. So we can say that the range is actually greater than 1. Okay. Obtain expression for f inverse and state the domain. Okay. Let fx be y. Y is equal to 1 plus 3 divided by x minus 2. There you go. Therefore, f inverse x is equal to 3 divided by x minus 2. Sorry, x minus 1 plus 2. And the domain of this will actually be the range of the normal function. So domain, it will be this one over here. Okay, are we clear? The function g is defined as this, gx for x is greater than 0. Obtain a simplified expression for g of x. I will input f into g. I will input f into g. F, which is 1 plus 3 by x minus 2. Okay, so that is 2 plus 6 divided by x minus 2 minus 2. So we get rid of these. We just end up with 6 divided by x minus 2. And yeah, logically that should be our answer. Pretty straightforward. So 8, 9, 10, 11. We are the end game of this paper. The diagram shows a graph of sine ax plus b, where a and b are positive constants. Okay, so as you can see, the graph has been shifted. It has been transformed by pi by 3. Okay. But there's another issue. Let's look into it. So the thing is, look at this. Sine twice 6, okay. So what happens is the period changes. The period changes, so instead of 360 or instead of 2 pi, the period changes into just pi. So as you can see, there has been a translation. It was originally supposed to be like this. It was supposed to be like this, okay. So as you can see, the actual graph, it's something like this, okay. So it's 2 pi over here and 4 pi over here. Okay, there you go. So if you want to find out the frequency, It's 2 pi divided by something, right? Is equal to pi. It should be 4 pi instead. It takes 4 pi to complete one revolution. So 2 pi divided by something on the front A is equal to 4 pi. So A is actually equal to half. That's how you find out A. Okay, so you can write this 2 pi divided by A is equal to 4 pi. So after simplification, A is actually equal to half. So we can write it like this: y is equal to sine half x half x plus b. Now the issue is this half also applies to b. It's kind of like this: y is equal to sine half x plus half b, kind of like this basically. Not the whole function, but inside. Okay, so here's the thing. Remember, for any horizontal translation, it's always the opposite. So I'll tell you the actual function. The actual function is like this: y is equal to sine half x, and as you can see, it is translated by pi by 3 to the left. So we should actually put a pi by 3 inside. Okay, there should be a pi by 3 inside. Do you get what I mean? So it's like this. So the answer is actually b should be equal to pi by 3. The reason being, the graph is shifted by pi by 3 to the left hand side, but when you do horizontal translations, you always have to do the opposite inside. That's the general idea. Okay, and it always goes with x. The translation goes with x and inside. And the curve with equation y is equal to fx has a single stationary point at pq, where p and q are constants. The curve is transformed to a curve with equation this. For the transformed curve, find the coordinates of the stationary point, giving you answer in terms of p and q. Let's do this. So y is equal to minus 3 if 1 by 4 x plus 8. So I want to describe what happened. Okay, so firstly, there are a few things that have happened over here. This graph has a translation of minus 80. Okay, and as you can see, the frequency also changes to 2 by divided by 1 by 4, which is 8 pi. It takes 8 pi to complete one revolution. Okay, but this isn't basically, they haven't said that this is trigonometric function. Okay, so let's just describe the transformations that have taken place. So a translation of minus 80, then this 1 by 4 over here, it's a horizontal stretch of stretch factor 4. Horizontal stretch of stretch factor 4, and then you also have a vertical stretch of stretch factor 3, as well as, since there's a minus sign in front of the function, what does that mean? A reflection on the x-axis. So let's try to think what happened over here. This is a unique question. The initial stationary point was, PQ. We need to know what has been affected. Okay, so these two affect the x coordinate. Okay, so how exactly? The horizontal stretch will actually quadruple the time the value of the x coordinate. Since it's a horizontal stretch of stretch factor 4, it will quadruple, so it becomes 4p, 4 times the original value, but this horizontal translation will decrease it by 8. That's the 8. That's the new x coordinate. And about the y coordinate, what happens? The vertical stretch will triple the value of q, it becomes 3q, but the reflection will convert the positive value into a negative value, or the negative value into a positive value. So it changes the sign essentially. So this is our answer. So hopefully you guys understood the logic behind this. It was pretty hard. I haven't seen a question like this before. So I figured out the transformations from this expression and then applied it. Anything horizontal affects the x coordinate, anything vertical, reflection of the x axis is vertical, anything vertical affects the y coordinate. Number 9, a curve has equation y is equal to 2x to the power half minus 1. Find the equation to the normal of the curve at this point. So dy by dx is equal to 2 into half into x to the power minus half minus 0. So we actually end up with x to the power minus half. So if you input x equals to 4, dy by dx is equal to 1 by root 4, which is 1 by 2. So the equation of the normal, the gradient of the normal, will be minus 2. So y minus 3 is equal to minus 2x minus 4, equation of the normal. Y minus 3 is equal to minus 2x plus 8. So y is equal to minus 2x plus 11. Perfect. A point is moving on the curve in such a way that the rate of increase of the x coordinate dx by dt. So dx by dt is equal to 3 cm per second. We have y is equal to 2x half minus 1. We also know that dy by dx is equal to x to the power minus half. So what will dy by dt be? It will be dy by dx into dx by dt, or basically the point is moving on the curve at a we are talking about at this particular point 4 3. So dy by dx, that is 1 by root 4, which is half, times dx by dt, which is 3. So that is basically 3 by 2. That is the rate of increase of the y coordinate. Okay, at a, the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of the y coordinate, is constant at 5 cm per second. As the point moves down the normal, find the rate of change of its x coordinate. Okay, this sum is a bit different because we had a curve, right, like this, but now at this particular point we are talking about the normal. So we can't use dy by dx anymore. We have to change it for, the gradient of the normal. That's the general idea. So we have to write for normal, dy by dx will actually be this is basically 1 by root x, right, dy by dx. So for the normal it will be minus root x, basically minus root x. Okay, and at a we are talking about a, so it's 4 3. So dy by dx is equal to minus root over 4, which is minus 2. Now, we want to find the change of its x coordinate, dx by dt. So dx by dt should be dx by dy into dy by dt. So dx by dy, it should be the reciprocal of this, minus half times dy by dt is minus 5, as it is decreasing at 5 cm per second. So the correct answer is minus minus, it's 5 by 2. 5 by 2 is the correct answer. So this was a relatively challenging question. Firstly, we had to change dy by dx for the normal rather than the tangent. Rather than using 1 by root x, I use the negative reciprocal, which is minus root x. I found out the value of dy by dx, and to find out dx by dt, we had to do dx by dy times dy by dt, and we ended up with 5 by 2. Okay. So we are here at the end of the paper, last two questions. Let's do this, final push. The diagram shows A, B, and C lying on a circle with center O and radius R. Angle AOB is 2.8 radians. The shaded region is bounded by two arcs. The upper arc is part of the circle with center O and radius R. The lower arc is part of a circle with center C and radius R. Okay. Center C, radius R, and the upper arc center O. Fine. Angle AOB is 2.8 radians. State the size of angle ACO. ACO. Okay, we got this actually. Because we know that these two angles, we can find it out. How? Basically, it's 2 pi minus 2.8 by 2. That's AOC. AOC is 2 pi minus 2.8 by 2. This is that one. And you know that this is an isosceles triangle. So these two should have the same values. So we can actually write this. X plus 2 pi minus 2.8 by 2 is equal to pi. So 2x plus 2 pi minus 2.8 by 2 is equal to pi, or 4x plus 2 pi minus 2.8 is equal to 2 pi. Then after further working, we can get rid of these. So it's actually 2.8 by 4. So 2.8 by 4 is 0.7 radians. So ACO is actually 0.7 radians. Perfect. That is how you do it. Nice. Find R, capital R, in terms of small r. Okay, the way to do this should actually be like this here. So you know that this is R, and you know this angle R. So we actually have to find this length first. Okay. How? Using trigonometry. Adjacent and hypotenuse. So we can write cos ACO is equal to adjacent. Let's call this length L, for example. Or that is actually R by 2, yeah? This length over here is R by 2. Is equal to R by 2 adjacent divided by hypotenuse R. So cos 0.7 is equal to R by 2 by R, or R by 2 is equal to R into cos 0.7, or R is equal to 2R times cos 0.7. So let's do that. It's in radians, cos 0.7 times 2. R is equal to 1.53 small r. I gave it to 3 singular figures because it wasn't specified, and it's an irrational number. So the actual one should be 1.52968 r. Okay, next, find the area of the shaded region. So how to do this? The area of this shaded region. The lower arc is part of the circle with center C, and the upper arc. Okay, So I think this is the bigger area, and we need to subtract this area over here. Okay, so the general idea is this. I'm going to find out this area first, and then I'm going to find out this area to subtract it, but then I have to add up. Okay, I have to add up these two triangles. Okay, that's the general idea. Hopefully you guys got it. I find out this big one and then this smaller sector, but I'm taking these two extra triangles away, so I need to add them up again. Okay, so let's go. So we go for sector AOB first. It will be half r squared theta, or half 2.8 squared theta. Sorry, half into what's the value of r? Oh, it's just r. 1.4 r squared. Okay. Next, we are going to find out the sector of ACB. Cap CAB. Half r squared theta. Sorry, Siri just responded to that for some reason. Okay, so what is this angle? It's actually 0.7 plus 0.7, right? So 1.4 rad. Half into, what's the radius? Capital R, right? Which is 1.53 r. Times 0.7 plus 0.7, which is 1.4. Because you know, this is 0.7 rad, this is also 0.7 times 2. And this whole length is capital R, which is 1.53 r basically, yeah? Okay. 1.53 square times 0.5 times 1.4, 1.63863 r square. Now we need to find out the area of triangle OCB. Okay, so we could go for half into base into height, or essentially half AB sine theta. I would prefer that. So we know that the value of this angle is this basically. So half AB sine theta. So half AB sine theta, half r square into sine theta. Theta being 2 pi minus 2.8 by 2. 2 pi minus 2.8 by 2. Sine answer into 0.5. That is 0.49272 r square. Okay. So now the area of the shaded region will be equal to, so let's start. Slow and steady wins the race. This big area, okay, which is 1.4 r square. Now minus this area over here, this pink one, which actually composes of 3 parts, yeah. So it composes of this triangle, and this one. So I'm basically subtracting this, so that is minus 1.63863 r square. But since I've excluded these two triangles, I'm going to add them up now again. So I'm going to add these triangles again to revert the scenario. Okay, so I'm going to add 2 times of 0.49272 r square. So let's see what we get. 63863. So to 3SF I'm getting 0.747 r square. Let's see if that matches. 0.747. Yes, I am correct. So hopefully you guys got it. I tried to simplify it as much as I could. Hopefully it makes sense for you guys. This was also tricky. It wasn't that hard, that easy, honestly. So we're at the last question now. The diagram shows part of the curve with equation y is equal to x plus 2 by 2x minus 1 whole square. The lines 1 and 2 intersect the curve at points P and Q respectively, and R is the stationary point of the curve. Verify that the x coordinate of R is 3 by 2 and the y, find out the y coordinate of R. Okay. So y is equal to x plus 2 divided by 2x minus 1 whole square. So dy by dx should be 1. Okay. Plus, honestly, this can be written like this. Plus 2x minus 1 to the power minus 3. Let's do it step by step. 1 plus 2 into minus 2. 2x minus 1 to the power minus 3 times 2. So that is basically 1. 2 to the 4, 4 to the 8. Minus 8 by 2x minus 1 cube. Now to find out the stationary point, we need to equate this with 0. So 1 minus 8 by 2x minus 1 cube is equal to 0. Or 1 is equal to 8 divided by 2x minus 1 cube. 2x minus 1 cube is equal to 8, or 2x minus 1 is equal to 2. 2x is equal to 3, so x is equal to 3 by 2 finally. Verified. Now find out the y coordinate. So y is equal to 3 by 2 plus 2 divided by 3 by 2 into 2 minus 1 whole square. So we can get rid of these. Y is equal to 3 by 2 plus 2 divided by 3 minus 1 whole square, which is 2 square. Y equals to 3 by 2 plus 2 by 4, which is half. So half plus 1.5, that is in fact 2. So we have our y coordinate now. Very good, guys. Moving on to the last question for the day. Find the exact value of the area of the shaded region. This shaded region over here. So we need the coordinates of P and Q first. We need the coordinates of P and Q. So let's do that. Y is equal to x plus 2 by 2x minus 1 whole square. So we input 1 first and 2. So if you input 1, you get y is equal to 1 plus 2 divided by 2 minus 1 whole square, which is 1 square. So it's 1 plus 2, which is 3. And if you input x equals to 2, then you get y is equal to 2 plus 2 divided by 4 minus 1 whole square, which is 3 whole square, 9. So 2 by 9 plus 2, that is 20 by 9. Okay. So now we have the coordinates. This is 1 and 3. This is 2 and 20 by 9. Perfect. So honestly speaking, you could just find out the area of this whole thing because it's a trapezium and the height is 1. Okay, so let's go for the area of the shaded region. So trapezium first, right? Half into height, which is 1, into a plus b. So what is a plus b? 3 plus 20 by 9. 3 plus 20 by 9. This is the trapezium. Minus integral of what exactly? X plus 2 into 2x minus 1 to the power minus 2 dx. So let's go for it. 20 by 9 plus 3 into 0.5, that is 47 by 18, minus, let's integrate this, x squared by 2 plus 2 into 2x minus 1 to the power minus 1 divided by 2 into minus 1. Limits are 2 and 1. So 47 by 18 minus x squared by 2. We can get rid of these. Minus 1 divided by 2x minus 1 to the power 1. Now even further, 47 by 18 minus, let's equate this, 4 by 2 minus 1 divided by 4 minus 1, which is 3, minus 1 by 2 plus 1 divided by 2 minus 1, which is 1. Okay, so 47 by 18 minus 2 minus 1 by 3 minus half plus 1, 2 minus 1 by 3 minus half minus 1, 1 by 6. So that is 47 by 18 minus 1 by 6. That gives me an answer of, let me check. Okay, let me just check again. 2 minus 1 by 3 minus half plus 1. That's 13 by 6. Sorry, 13 by 6. So 47 by 18 minus 13 by 6 gives me an answer of 4 by 9. Let me check with the mark scheme. Yes, that is the correct answer. Okay, guys, that is it for today. I will be launching more math papers soon after the May June 2024 series is out. Hopefully my channel has it out before any other page officially. Anyway, hopefully I could help you guys solve this paper. Hopefully I could give concise answers to your questions. And if you have any other queries, please feel free to comment down below. A quick shout out to my top tier patron for the month, Tim. He has been supporting me for quite some time. We have had a few meetings. So if you want to be featured at the end of the screen for all my other videos, please consider supporting me on Patreon on the highest tier, where you get access to many perks as well as video meetings with me where we can solve your personalized problems. Anyway, I'll attach a link for the October-November 2023 paper 1-1 up here, and the October-November 2023 paper 1-2 down here, and the playlist for 9709 Pure Math 1 up here. And remember to hit the subscribe button. See you guys. Bye bye.